And here the function a0, a1, a2, and d are the continuous functions. And if you suppose y1, y2 be two linearly independent solutions, so this is your equation number one. Basically, we rewrite all those equations. Okay, so and if y1, y2 be the solutions of this linearly independent solution of homogeneous differential equation, this means that this ds part is zero. So if we write what is your homogeneous differential equation, so this is a naught x this equals to zero. This is your homogeneous differential equation. And if y1 and y2 be two linearly independent solution of this linearly homogeneous differential equation, then you can find the general solution of this is y equals to c1 of y1x plus this is the linear combination of that two. Okay, be the general solution of this equation number two. And if we suppose this is a general solution, and if we to find this c1 and c2 are the parameter which depends on x, then in that case your particular integral is looks like u1 and u2 if okay, and say this is equation number three. Okay, so that part is already done, and this satisfies equation number three. Okay, so here you can find out what is the differential of this part. So this part is you can find easily. This is y1 prime unx, and this is y2 prime u2x plus y1 u1 prime plus y2 u2 prime. Okay, and here you said this thing is zero because you don't switch to this second order u1 and u2. So this equation satisfies the condition, and that one is y1 and ux plus y2x u2 prime x that equals to 0. This is your equation number 4. And from if we this part is 0, then this equals to your y p prime. This is equals to y1 x u1 x this part plus y2 prime u2x. Okay, so this is equation number 5. And if we differentiate this equation, so you can get this is u1 prime y1 prime u1 y1 double prime u2 prime y2 prime u2 and y2 double prime. This is equation number 6. Okay, so here this part is already done in our previous class. And if you substitute equation number 3, this equation 5 and 6, and you substitute this in your main equation, this one. Okay, so if we here y double prime here, y prime this, and y. Okay, so if you putting this thing, so you get the result, and the result is in next page. Uh, in next page, we if we substitute this equation 3, 5, 6 in equation number 1, so here we get this a naught x y1 prime plus a1x y1 prime plus a2x this thing by combination of that part if we take a u1 common. And this part is already done in previous class. So I have just quickly rewrite all those equations and only the last part was left at in that lecture. So here you can, if you putting equation number 3, 5 and 6 in equation number 1, so you get this results. Okay, you get this result. Okay, so now we get this relation, and here we know that the y1 and y2 are the solution of equation number 2. Okay, what is equation number 2? So equation number 2 is, if we here write what is equation number 2, so equation number 2 is a naught x y double prime plus a1x y prime x plus a2 yx, that equals to 0. If y1 and y2, we are solutions of that equation, then this y1 must satisfy this equation number 2 and of course y2. Okay, so here if we put y1 here, if y1 satisfies, then a naught x y1 double prime, plus a1x a y1 prime plus a2x y1x. Okay, so this term is 0 if y1 is the solution of this equation number 2. Similarly, if y2 is the solution of this equation number 2, so this condition, that portion is also equals to 0. Okay, so here we write, since y1 and y2 are solutions of equation 2, so we get only this part, and this part is u1 prime a naught x and into y1 prime plus u2 prime, and this is a naught x y2 prime, that equals to dx. Or we can rearrange this term like y1 prime is function of x, u1 prime x, if we take a naught x with a common and divide this right hand side, so this becomes u2, okay, y2 prime x, u2 prime x, and that equals to dx over a naught x. Okay, and this is your equation number 7. Okay, so I think up to here we had already discussed in last class. Okay, so now our aim is to find what is u1x and what is u2x. Okay, and equation number 4 is this is equation number 2 and what is equation number 4? Equation number 4 is y1x and u1 prime x plus y2x and u2 prime x, that equals to 0. You have, okay, this is your equation number 4. Okay, so under that condition, if you take this term is 0, so we using these two and try to find what is the value of u1 that satisfies equation number 7 and of course 4. Okay, so here if we write equation number 4 and equation number 7, so if we multiply by the term, say if we suppose if you multiply it by u2 prime, so here this coefficient is y2 prime and here y2x. So if we multiply this term by y2 prime, okay, so if we multiply this equation by say y2 prime, okay, and this equation we multiply y2. Okay, so this term is y2 prime, and here this term is y2 prime. Okay, so now your equation is if you multiply by y2, so this becomes y2x y1 prime x u1 prime x plus y2x y2 prime x u2 prime x that equals to y2x dx over e naught x. This is equation number 7 after multiplying by y2. And here in this term, if we multiply by y2 prime, so this becomes y2 prime x y1 x plus and u1 okay, plus u1 prime x plus y2x, and if we multiply by y2 prime this term and u2 prime x, and here right hand side is 0. Okay, and if we try to find what is the value of u1 prime, so we if we subtract this term, so this term is cancelled out. Okay, so now your term is this equals to this thing. So this implies you can here u1 prime is common. So u1 prime x is common. And this first term is y1 prime x y2x minus y1x y2 prime x. Okay, and that equals to this dx over a naught x. Okay, and what is the Roskian? If we go through this, what is the Roskian of that two function? So this is the determinant simply y1x, y2x, y1 prime x, y2 prime x. Okay, so determinant of this is equals to y1x, y2 prime x minus y2x, y1 prime x. Okay, so here you can check what is the value of this thing. So here y1x y2 prime x. Okay, so if we take the minus sign, if we multiply it by minus to both sides, so this term is becomes Roskian of y1 y2. Okay, so now you can get here this implies you can this u1x equals to minus of y2x y2x dx over a naught x, and this term is if we minus if we multiply by minus sign, this becomes Roskian of y1 y2
Say u1 prime x na.
u1 prime, of course u1 prime u1 prime. Okay, thank you. This is u1 prime. Okay, okay, u1 prime, this is u1 prime. Okay, so u1 prime equals to this thing. Okay, and similarly if we multiplied this equation by suppose this term, if we eliminate u1 prime term and we are interested to find u2 prime, so if we multiply it by this is y1, okay, and in this term y1 prime, and now subtracting that those term. Okay, so in next page we will find the next term, that is u1 u2 prime. Okay, so next page our equation is okay, so here we can find this u1, we have u1 prime is equals to uh, minus of y2x dx over a naught x Roskian of y1 y2. Okay, so this thing we can find, we had already find. Okay, and what is your equation number is 7 is y1 prime u1 prime plus y2 prime u2 prime, that equals to dx over a naught x, and if we multiply it by that it's y1 term, and equation number 4 is y1 u1 prime plus y2 u2 prime that equals to 0, and if we multiply it by this y1 prime. Okay, so this term is cancelled out. Okay, I'm now subtracting that term. So this term is cancelled, and this term is y1 y2 prime u2 prime minus y1 prime y2 u2 prime, that equals to y1 dx over a naught x. Okay, so you can find u2 prime, that is a function of x, of course, and multiplied by y1x y2 prime x. Okay, so minus y1 prime x and y2x. Okay, and that equals to y1 dx over a naught x. So this implies your y2 prime x is equals to y1 dx over a naught x, and this is the Roskian of y1 y2. Okay, so this is your y1 prime, and this is u2 prime, u1 prime and u2 prime, that equals to defined by this equation. Okay, and say this equation is something 8. Okay, so what is here Roskian? So what is y1 and y2 is the Roskian of the solution y1 and y2. Okay, so we are interested to find this, what is un function. So un x, that equals to, simple, if we integrate, this is y2x dx a naught x, and Roskian of y1x y2x, at this term, and this differentiate with dx. Okay, so d is a function of x here, this d is a function of x, and this is the integral. Okay, so this is dx, and similarly you u2x is equals to integral y1x dx, and this is a naught x Roskian of y1x and y2x, and integrate this over x. Okay, so this is your u1 and u2. So what about your particular integral yp? So then your particular integral, that is u1x and y1x plus u2x and y2x. So this is your particular integral, where u1 and u2 are defined by, you can obtain by this relation, that is equation number 9. Okay, from equation 9 you can find this 10. Okay, so by this method you can find easily what is the particular integral of any non-homogeneous differential equation. Okay, so here if we consider second order differential equation, so okay, so now the next topic is a system of linear differential equation. Okay, so so next topic is system of linear differential equations. Okay, so in general, basically the differential equation of order 1 is of the form, we can write y prime, that is a function of xy. Okay, and when this axis belongs to an interval. Okay, and here this I is an interval, and this y be the function from this I to real R. Okay, and what is f is? F is basically I cross R to this mapping. Okay, so here the first order linear non-homogeneous equation, we can write here the first order linear non-homogeneous differential equation. This is defined like y prime plus some constant which is function of x, y, that equals to bx, and so this is non-homogeneous due to this bx part. If this bx equals to 0, this is homogeneous. So we can generalize this above equations by, so we can generalize the above equation. So if we assume that this n be any finite positive integer, so if we consider different functions f1, f2 up to fn, so if we consider f1, f2 up to say fn, and that is from I cross d to this domain, this b and real valued functions, which is defined on that open connected set D. This is a real valued function, which is defined on an open connected set. Basically, this is of element of that Rn. Okay, so this is open connected set D, which is subset of Rn because there are n. Okay, so if we consider a system of equation, if we write, consider system of equations, and we write like this yi prime. Okay, this equals to fi. There are n functions, and all are the x and y1, y2 up to yn. So there are n linear first order differential equations. So here we can write I equals to 1 to up to n. And okay, so here this all y1, y2, y3 up to yn are real valued functions. This is real valued functions, and to be determined by, if we have to find out that what is the value of y1, y2, y3, and so on. Okay, so these values has, we have to determine what is this thing. Okay, so here this y1, y2 to yn are real valued function, and that function we have to determine. Okay, so this we have to find. Okay, so if we assume that this in I with the interval, this is a real intervals, this is subset of R, be an interval, and let the functions, suppose we take like aij, and your constant one is suppose bj. If this is a function from that interval I to R, And if we rewrite this system of equations 3 as okay, so next page okay, so next page we write here what is rewrite this equation number 3. Okay, so here if we assume that this interval I, which is the real interval, be an interval, and let the functions, which is aij and say bj, that is from I to r, and ij is varies from of course 1 to n. So this be given, and consider a system of equations of, and that equation is y1 prime is a11x, this is a12x, y2, and say a1nx, this is yn. Okay, so y1 prime, this is the first equation. Okay, and this plus say b1x. Okay, constant one. Suppose similarly here y2 prime is this is another coefficient, say a2x, say a22x, and a2nx, y1 plus some arbitrary function b2. Similarly, what is your yn prime? This equals to a1x, this is y1, a and 2x, y2, and a nn, this is yn plus bnx. Okay, and this is your system of equation, that is equation number 4, and here of course x is belongs to that interval I. Okay, so this equation 4, basically this is your main equation. The equation 4 is called general non-homogeneous system, okay, of how many equations? So n equations. So this is this thing. Okay, and if we write this in compact form, so if we rewrite this by in fi, and that is the function of y1, y2 up to yn, and that equals to a of I1, y1, a of I2, y2, and of course this is a function of x, and say a of in, yn.
सर वो बाय क्या लिखा है
हेलो
आपने?
सर
हाँ हाँ
हेलो बाई के बाद सर क्या लिखा हुआ है
कहाँ पे लाइन नंबर
बाई बाई के बाद
while letting
लास्ट लाइन
letting LETTING.
थैंक यू सर
ओके, सो by letting थोड़ा स्पीड बढ़ा दिया है तो थोड़ी राइटिंग में प्रॉब्लम है, तो आपको जहां भी प्रॉब्लम हो पूछ सकते हैं. सो by letting this I1x and this thing like here. Okay, so for general, if we take I equals to 1 to first equation, I equals to second, and so on. Okay, so this is general Vix. Okay, for this I equals to 1 to n. Okay, so we see that this equation number 4 is this equation number 4. If look like this equation number 4 is the special case of our system that is equation number 3. Okay, so now here we can write this thing. We see that A1 2x and say A1 and x, A2 and x, A2 2x, A2 and A and 1x, A and 2x up to A and n x. Okay, so if we define this matrix and for x belongs to I, we define a vector, suppose bx and yx by uh, like this. If bx is the column vector whose components are b1, b2 up to bn, and what is yx? So yx is y1, y2, if we define this thing. So if we define these things, so our equation, that is I think equation number 4. Okay, so equation 4 can be rewrite as y prime, that equals to ax, that is matrix, into yx, that portion, okay, and plus bx. So this system of equation we can write in matrix form. Okay, and when this bx is 0 on that given interval, then the above equation is linear homogeneous system of differential equations. Okay, so if this part is 0, if bx part is 0, then this is a system of homogeneous system of differential equation. If bx part is this vector is null vector, then that says this is a homogeneous, and if this is a non-zero vector, then this is non-homogeneous system of differential equation. Okay, so this is basically the theoretical background of system of equation, of any system of equation you can write in this matrix form, and here you can obtain what is the matrix A, and where you can use of this matrix A by using the eigenvalues, you can find the solution of that system of differential equation. Okay, so if we take a simple example, and that is suppose if we take two variable, so two system of equations, and try to find how to what is the solution of that system of equation. Okay, and then we go through the larger problem. Okay, so first of all we take a simple example in next page. We consider a system of equations which is defined like so if we consider a system, if we consider system of equations, and that equation is defined like y1 prime is equals to 5y1 2y2. Okay, and second is y2 prime is equals to 2y1 plus y2. Okay, so if this is your system of equation, so this system of equation you can write this in matrix form. So you can write it has a form y1 y2 prime. Okay, so this equals to, you can write here, this is constant coefficient, so 5 minus 2, 2 and 1, and if we multiply it by, this is y1 y2. Okay, and here this b term is absent. Okay, this is system of homogeneous system of equations. Okay, so here this is y prime is dy1 over dx, that equals to 5 of y1 minus 2 y2, and here dy2 over dx, that equals to this thing. So this system of equation you can write in this matrix form. Okay, and if we relate this, this is in the form of y prime, that equals to matrix A. Here, this is the constant coefficient. So this is AX be the constant matrix. Okay, and this into y with the vector. Okay, so what is y here? So here y is y1, y2 column vector. Okay, so what is here A with a constant matrix whose components are 5 minus 2 and 2 and 1. Okay, so here if we are interested to find what is the eigenvalues of this matrix, so here you can find A minus lambda I, that equals to 5 minus lambda, this is minus 2, this is 2, 1 minus lambda. Okay, and that equals to 0. This implies we can obtain here 5 minus lambda into 1 minus lambda minus and minus plus, that is 4, equals to 0. So this implies you can find lambda square, and 516, that is 6 lambda plus 9. So that equals to 0. So here you can find lambda equals to a square plus b square minus 2ab. Okay, so this is plus 3 and plus 3. Okay, so both roots are equal. Both roots are equal. So then, what is the solution? What is our y1x? So y1x is c1 plus c2x, because both roots are same. So this into e to the power, what is lambda x? So lambda x is 3x. Okay, so this is the solution of that. And if we putting this y1x in any equation number, first equation, then you can find easily what is y2. Okay, so if we putting y1x in first equation, so we get this y1 prime means d over dx. What is y1 is c1 plus c2x e to the power 3x, and that equals to 5 of y1. So y1 is c1 plus c2x e to the power 3x minus 2 y2x. So on solving this, you can find what is the value. So this is 3c1 e to the power 3x plus 3c2x e to the power 3x plus c2 e to the power 3x, and that equals to 5c1 e to the power 3x plus 5c2 to the power 3x minus 2 y2x. Okay, so here we can solve this. So your solution is basically y1x is c1 plus c2x e to the power 3x, and y2x from here. So if we subtract this term c1 and c2, so this is equals to c1 e to the power 3x and the c2x to the power 3x minus e to the power 3x. Okay, so if we divide it by 2, so this is your final solution where you can find y1x and y2x. Okay, so similarly, if there is a suppose system of equations in which y1 prime, y2 prime, and y3 prime are functions of y1, y2, and y3. Okay, so in that sense, you obtain a matrix in the form of y prime equals to this thing, and try to find the eigenvalues, and then your first solution is y1x, that is in that form. Okay, depending on the roots of eigenvalues. Okay, so if you find y1x, then you put in here. Okay, and then try to solve that equation, and by using second one, then you can, and third one, you can obtain the results for y1, y2, y3 independently. Okay, so if we consider the nth order differential equation, and uh, how do we obtain the matrix A and what is called a matrix A, and so on. Okay, so that part we will discuss in next class. In next class, here one additional thing is we will explore more about that this form. Okay, so this is the starting one. Okay, here we use this term and how to find the fundamental matrix and so on. Okay, so in next class we will discuss about if our the differential equation of an nth order, then how can we that nth order differential equation can reduce in the form of system of differential equation. Okay, so and okay, so if we write that term is okay, so okay, so now I think time is 47. Okay, so now completed that part. Okay, so in next page, and nth order differential equation of the form, if we have nth order differential equation which is defined like this yn means nth order derivative. Okay, and a1x y n minus 1 plus a2, this is n minus 2, and suppose this is the last one is an y, and that equals to vx, and of course that axis belongs to any real interval I. Okay, so this is called linear non-homogeneous due to bx part, non-homogeneous nth order differential equations. Okay, so and that is equivalent. This is equivalent to if we rewrite this yn plus a1x of a naught x. This is standard form of this coefficient becomes dating coefficient becomes 1. Okay, so this is a2x on a naught x, and this is equivalent to this an over a naught x, and this is y. Okay, and this equals to bx. Okay, so here one thing is remember that a naught x, this a naught x not equals to 0. Okay, a naught x is not equals to 0, because if a naught x equals to 0 for any interval, say x equals to x naught, which belongs to that interval, so that point is known as singular point. Okay, and here this term is not defined. Okay, so that is a similar point if a naught x equals to 0 for any x which belongs to that interval. Okay, so that's why here we consider here this a naught x is not equals to 0. Okay, so if we assume that, so by if we assume that our y1 is simply y. Okay, so if you consider y1 is y, and what is your y1 prime? Y1 prime is your y2, and y2 prime is y3, and yn minus 1 prime, that equals to yn. So this is equation number 2 if we assume that notation. So from equation first and second, we get this yn. So yn, and this yn, because what is yn minus 1, and this becomes yn prime, and okay, this is a1x over a naught x yn minus 1, this is yn, and a2x over a naught x, this is yn minus 1, and an minus 1x over a naught x, that is y2, and anx, last one, over a naught x, this is y, means y1, so this is y1, and that equals to bx over a naught x. Okay, so here you can rewrite this equation like y1 prime is minus anx denote a naught x y1 minus an minus 1 a naught x y2, and minus a2x upon a naught x y n minus 1, and this term, if we go to left hand side, this becomes a1x on
सर प्राइम वाले टर्म को रिप्लेस करेंगे ना, तो इक्वेशन 1 और 2 के बाद कैसे लिखें?
okay, and this plus bx over a naught x. Okay, so okay, so here this term here, if we this term left from here, this term, if we move from right hand side, so all sign are negative, and here first one is minus a naught an upon a naught x y1, second term is this y1, then y2, okay, then y3 y4, and so on. Here this term is yn minus 1, and last term is this into yn. Okay, this is y, sorry, this is yn. This is y1. Minus of a naught x, and here this right hand side is bx over this thing. So this equation is yn prime equals to that term. Okay.
सर
तो
फ्रॉम इक्वेशन 1 and 2 वी गेट उस लाइन को और एक बार एक्सप्लेन कर दीजिए ना कैसे हुआ वो।
okay. From one equation one and two, if we assume that if y1 is y and y1 prime, if we differentiate this equals to y2, and if differentiate this y2, this becomes if we y3, and if differentiate y3, this becomes y4 prime, okay, and so on. If we assume that this thing, okay, so here your y n, that is the nth derivative of that y. So this becomes simply your yn prime. Clear? ये clear है कि नहीं है? And
Yes,
then
sir.
clear नहीं हो रहा है? आप
Yes,
इसे
sir.
आप अपनी इक्वेशन है, ये आपकी इक्वेशन है, ये सारी इक्वेशन नंबर 1. ओके, इक्वेशन नंबर 1 में दिस इज y मींस y. ओके, इसके जस्ट पहले y प्राइम मींस हो गया dy ओवर dx. ओके, एंड सिमिलरली y2 मींस y स्क्वायर जो होगा वो होगा d2y ओवर dx स्क्वायर. सिमिलरली हियर yn मींस dy by dx nth ऑर्डर dny by dx n. ठीक है, तो हमने एज्यूम कर लिया कि अगर हमारा जो y है, दिस y इज जो वेरिएबल y है, दैट इज अगर उसको हम एक वेरिएबल हम y1 ले लें, ओके, और इसका जो फर्स्ट ऑर्डर डेरिवेटिव है उसको हम y2 कहें, और y2 की जो डेरिवेटिव है उसे हम y3 कहें, और इस तरह से हम उसको एज्यूम कर लें. सारे वेरिएबल हमने y1 y2 y3 y4 एंड yn हमने डिफाइन कर लिए. देन जो फर्स्ट ऑर्डर डेरिवेटिव होगी वो हमारी जो सिंपल जो y है, जो टर्म y है, दैट इज योर y1. तो y की जगह हमने y1 लिख लिया. क्लियर? यहाँ पे हमारा क्या होगा, यहाँ होगा हमारा से जस्ट पहले क्या होगा, यहाँ पे y2 सेकंड ऑर्डर डेरिवेटिव होगी, एंड दैट y2 मींस ओके, हम यहाँ पे एक लास्ट टर्म इसकी लिखते हैं. n से पहले है हमारा टर्म, दैट इज an minus 1x over a naught x y2 की पावर 2. ओके, not y2 means नहीं, y2 y square. Okay, because in that form, so y2 means this is the second order derivative of y. Okay, so this means d2y by dx square, and dy by dx is your y1, and if we differentiate that in 2 times, that is your y2. So if we differentiate 2 times, that is your y2. This part is clear or not? This part is clear?
Yes, sir.
ये पार्ट आपको क्लियर हो रहा है? आप इधर से ना आओ, आप इस साइड से स्टार्ट करो, इस साइड से स्टार्ट करो. थोड़ा आप इसको थोड़ा ध्यान से खुद से करना, तो आपको समझ में आएगा क्या चीज है. तो y को हमने y1 ले लिया, तो हमारा जो नेक्स्ट डेरिवेटिव जो होगा दैट इज योर y2. सिमिलरली जो नेक्स्ट डेरिवेटिव होगा दैट इज योर y3. ओके, फिर उसका जो डेरिवेटिव होगा y4, उसका डेरिवेटिव होगा y5 एंड सो ऑन. दिस लास्ट पार्ट इज योर nth डेरिवेटिव, दैट इज योर yn. ओके, ठीक है. एंड नेक्स्ट डेरिवेटिव मींस इसकी हमने क्या की, डेरिवेटिव ले ली इसकी, क्योंकि इसकी क्या है, एक डेरिवेटिव और कर रहे हो ना, yn minus 1 है, फिर इसकी डेरिवेटिव एक बार और डेरिवेटिव लोगे d over dx of that is yn. ओके, so if we differentiate this over x, this becomes yn prime. क्लियर है ये चीज, या मैं इसको और अलग से करके दिखाऊं?
नहीं से क्लियर हुआ.
कुछ क्लियर हुआ इसमें, देख रहे हैं आप इधर से जाओगे तो इधर से जाओगे तो आपको कंफ्यूजन होगी. इधर से मत जाओ, आप इस साइड से स्टार्ट करो, लोअर ऑर्डर से स्टार्ट करो. देखो कि ये अगर एसेंशन हम लेते हैं तो हमारे सारे y1 y2 अप टू yn तक ये यहाँ तक आ जाएंगे. क्लियर? yn तक आएंगे. ठीक, अब लेकिन नेक्स्ट वन हमारा क्या है, दिस इज yn मींस क्या, दिस इज डेरिवेटिव ऑफ एक ऑर्डर की और डेरिवेटिव है, दिस इज d by dx ऑफ yn minus 1, दैट इज योर yn. तो दिस मींस इसकी आप क्या कर रहे हो, एक डेरिवेटिव ले रहे हो, दैट इज yn प्राइम. क्लियर? ठीक है. और ये
एक्चुअली सर
yn प्राइम इक्वल्स टू ऑल टर्म्स को आप क्या करो, राइट हैंड साइड में ले जाओ. तो राइट हैंड साइड में जाओगे तो सबकी साइन क्या होगी, हमारी नेगेटिव हो जाएगी. ओके, एंड एक्सेप्ट फ्रॉम दिस इज bx plus a naught x. क्लियर? ये पार्ट क्लियर?
सर y की तो डेरिवेटिव ले रहे हैं इन टर्म.
क्या क्या
एक्चुअल
हाँ
y की तो डेरिवेटिव ले रहे हैं nth बार।
एन वाई एन माइनस कौन कौन सा टर्म
नहीं
है?
नहीं, हाँ वो तो nth हो रहा है ना, nth टाइम डेरिवेटिव हो रहा है y का ही तो।
हाँ 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 हाँ
एक्चुअली y को
this equation number one is nth order differential equation. Okay, but here this equation, if we assume this thing, so this is our variable y1, y2, y3, y4 up to yn. These are the nth n variable. ये जो अगर आप ये सब्स्टिट्यूशन ले लें और इसको आप another variable y1, y2, y3 अप टू yn अगर आप एज्यूम करते हो, तो आपका जो nth ऑर्डर डिफरेंशियल इक्वेशन है ये आपकी इस फॉर्म में होगी, जो कि आपके y1, y2 अप टू yn, ये आपके अलग अलग वेरिएबल्स हुए। ओके, क्लियर?
ओके सर।
ठीक है, ठीक।
ओके सर।
इस फॉर्म को आप क्या कर सकते हो, आप मैट्रिक्स फॉर्म में लिख सकते हो। तो मैं थोड़ा 2 मिनट और ले लूँ आपका, 11 बज गए हैं, 2 मिनट और ले लेता हूँ। ठीक, बस 2 मिनट। ओके, सो नेक्स्ट पेज इसे कंप्लीट कर दूंगा। So next page, we can write what is your y. So y basically your column matrix. This is column vector basically y1 to yn. What is dx is 0 0 0 dx over a naught x, and what is ax is 0 1 0 0। कैसे होगा हम इसे नेक्स्ट टर्म पे हम बताएंगे। बस हम इसे लिख देते हैं, और अगर आप रिलेट करें तो इजी भी है, ऐसा नहीं है। एंड लास्ट टर्म इज an over a naught, second term is minus an minus 1 over a naught, third term is minus an minus 2 a naught, and last one is a1 over a naught. Okay, so this is your matrix, and the system of equation, that is 3. This can be written as y prime equals to axy plus dx, where x belongs to this thing. Okay, and here equation 3 and 4, these are equivalent because we have find from that. Okay, equation number 3 and 4 are equivalent. ये मैट्रिक्स ए कैसे लिखा है, इसको आप जरा रिलेट करना। कैसे लिखा है, नहीं होगा तो मैं कल मेरी क्लास है, हम कल इसको एक्सप्लेन कर देंगे ये पोर्शन। ठीक है, ये पोर्शन थोड़ा सा छूट रहा था, तो आज हम इतना करते हैं और कल कुछ न्यूमेरिकल्स भी इसके हम करेंगे। ठीक है, तो इसमें बहुत परेशान नहीं होना कि व्हाट इज bx और ax, हम कल इस चीज से हम स्टार्ट करेंगे, यहीं से स्टार्ट करेंगे। ओके, ठीक है, अब आपकी क्लास होगी, आप जाइए, आज के लिए इतना। ओके, थैंक यू
सर।
थैंक यू सर।
सर।
Thank you, sir.
ओके, थैंक यू।
थैंक यू सर। थैंक यू सर।